work on scientific notation. So your first blank, scientific notation, is how mathematicians and scientists handle very large or very small numbers. Okay. So what is scientific notation? When you see a number written in this form, so you have a decimal times 10 to a power, this is called scientific notation. This number right here has to be between 1 and 10. So it has to be more than 1, but less than 10. The exponent over here tells us how many times we're going to move the decimal to get this into standard form. So 6.8 times 10 to the 8th, this is scientific notation, and we're going to convert that to standard form. So we have 6.8, and then this exponent of 8 tells us we are going to move the decimal 8 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8. And then for all these empty loops, you're going to add a 0. So 6.8 times 10 to the 8th in standard form is 680 million. When your exponent is positive, you're going to move your decimal to the right. So let's look at our next example. We have 2.9, which is between 1 and 10. This time our exponent is -2. So for our first example, when our exponent was positive, we moved our decimal to the right. If our exponent is negative, that means we're going to move our decimal that many places to the left. So in the end, our answer ends up being 0.029. So if your exponent's positive, you're going to move it to the right, and your number is going to get larger. If your exponent is negative, you're going to move the decimal to the left, and your number is going to get smaller. Our next section is over converting from standard form to scientific notation. So here we have standard form of 65 million. For scientific notation, we're going to start by writing our times 10. That never changes. In your standard form, you need to find a place where you can put the decimal that would give you a number that's between 1 and 10. If I put the decimal here, I would have 65, and that's too big. So I'm going to put the decimal between the 6 and the 5, which would be 6.5. So because that's between 1 and 10, it's going to go over here. We get 6.5 times 10, and then we need to see how far we would have to move the decimal to get it to 65 million. So we're going to move it once, 2, 3, 4, 5, 6, 7. We moved it 7 times to the right, so my exponent is a positive 7. Okay. We have 0.0056. So first thing we're going to do, write our times 10, because that never changes. We're going to put our decimal between the 5 and the 6, because that's going to give us a number between 1 and 10. We get 5.6. Now we have to count how far we would have to move the new decimal to get it back to the original. So we're going to go back 1, 2, 3. And because we moved to the left this time, our exponent is going to be -3. Okay. When you're done with that, go ahead and grab your ISN. The date is 8/21. These are your scientific notation notes, and those are going to go on page 13. So find your divider. Make sure you label at the top that this is a video so you can go back and reference it later. And then just tape or glue that in to your ISN.